Guys, my name is Himanshu and I am studying in Sri Venkateswara College of Engineering in Computer Science Engineering Cybersecurity branch, and today's topic is criteria for selection of landfill and urban flood control. Criteria for selection of landfill. The selection of landfill site involves evaluating multiple criteria to ensure it is environmentally sound, cost effective, and socially acceptable. Below are the key criteria to consider: site location, technical feasibility, geology and hydrogeology, socio-economic considerations, environmental and climatic factor, legal and regulatory requirements, land use and zoning, economic feasibility, risk management. Site location: proximity to population. Landfills must be located far from residential areas to minimize negative effects such as odor, noise, dust, and potential health hazards. Proximity to waste source. The closer the site is to waste generation areas, the lower the transportation cost and greenhouse gas emissions from hauling trucks. Accessibility. Sites must be easily accessible year-round with proper road infrastructure that can handle the frequent movement of heavy trucks carrying waste. Geology and hydrogeology, soil type. The site should ideally have clay or other low permeability soils to act as a natural barrier, reducing the risk of leachate infiltration into the groundwater. Groundwater vulnerability. Sites near shallow aquifers or those with high groundwater tables are unsuitable as they increase the risk of groundwater contamination. Areas with deep water tables are preferred. Natural barriers. Features like surrounding hills or impermeable rock formations enhance the safety of the landfill, providing secondary protection against contamination. Environmental and climatic factors. Surface water proximity. Sites must not be located near rivers, lakes, wetlands, or reservoirs to avoid the risk of leachate contaminating surface water sources. This requires adherence to regulations specifying minimum distances from water bodies. Flood risk. Avoid low-lying areas prone to flooding as excess water can overwhelm landfill systems, increasing leachate productions and risk of surface water contamination. Wind and climate. Consider prevailing wind directions to reduce the impact of odors, dust, and waste debris on surrounding communities. This helps in selecting a site where wind-blown waste will not affect critical areas. Land use and zoning. Compliance with land use plans. The site must align with local zoning regulations and future urban or rural development plans. Misalignment with land use plans can lead to legal disputes and operational challenges. Compatibility with surrounding land uses. Ensure the site is not near areas of recreational, conservation, agriculture, or other significant land uses. A landfill near such areas can generate resistance from stakeholders and regulators. Technical feasibility, site capacity. The selected site should have sufficient capacity to handle both current waste disposal needs and projected future demands over the landfill's operational lifespan. Slope and topography. Gently sloping and minimizes construction cost and providing natural drainage management. Steep slopes increase the risk of instability, while flat areas require significant drainage system. Cover material availability. Daily cover materials such as soil are required to minimize odors, control pests, and manage landfill fires. The availability of these materials near the site is an important consideration to reduce operational costs. Socio-economic considerations, community acceptance. Public opposition can hinder landfill development involving local communities early in the process to address concerns helps gain acceptance and ensures a smoother approval process. Cultural or historical sites. Landfills should not be built on or near areas of archaeological, historical, or cultural significance. Disturbing these areas can result in socio backlash and potential legal penalties. Legal and regulatory requirements, compliance with environmental laws, adherence to regulations for the site design, construction and operation is mandatory. This includes measures for managing leachate, landfill gas, and proper waste segregation. Setbacks and buffers. Regulators often require specific setbacks, example distances from residents, water bodies, and roads. To migrate risk, these must be adhered to during the site selection. Economic feasibility, cost of acquisition and operation. Land acquisition, site development, and maintenance costs are critical preference should be given to sites that balance affordability with environmental and operational feasibility. Longevity. The site should have enough capacity to sustain operations for at least 20 to 30 years, depending on the waste generation rates and population growth. Risk management. Natural hazards. Sites prone to earthquakes, landslides, or subsidence are unsuitable. Geotechnical studies should confirm site stability under dynamic and state loads. Environmental monitoring. The site should be designed to allow effective monitoring system for detecting leachate movement, gas emission, and water quality. Urban flood control. What are urban flood? Urban flooding describes the flooding of the land of property within a constructed environment, especially in locations that are more densely inhabited, like cities, as a result of excessive rainfall that exceeds the capacity of drainage system. Urban flooding is significantly different from rural flooding, as urbanization leads to development catchments, which increases the flood peaks from 1.8 to 8 times and flood volumes by up to 6 times. Consequently, urban flooding occurs very quickly due to faster flow times, which is in a matter of minutes. Causes of urban flood: higher rainfall, storm surges and frequent depressions in open waters, depleting groundwater tables, heavy melting of snow causes flash floods in lower catchment areas, rising sea levels due to global warming, encroachment on drainage areas like lakes, wetlands, and riverbeds, close of ways for the excess water to flow, this causing floods. Climate change has disrupted the rainfall pattern. Urban heatlands have increased rainfall over urban areas, resulting in flooding. Pollution of water bodies is choking up the pathways for excess water to flow. Illegal mining activities in rivers deplete the natural bed, causing soil erosion and reducing the water retention capacity of the water body. Unplanned and uninformed release of water from dams cause devastation as the public does not get enough time to respond. Controlling methods. Build away from floodplains and flood-prone areas. This is the best way to ensure less loss of life and property. The development of blue-green infrastructure will be effective in providing sustainable solutions to urban climate challenges. Better water management should be ensured, like including rainwater harvesting in all infrastructure developments. Geospatial technology should be utilized for flood vulnerability mapping, which will aid in better planning for development. The natural water bodies should be strictly regulated and maintained to ensure the free flow of excess water. Water bodies should be made clear of pollution and encroachment, and drainage systems should be regularly maintained. More awareness and education of residents are needed to make them know of the risks and responsibilities of dwelling in flood prone areas. Thank you, guys.